Our current implementation and modeling of the entity type is satisfactory, both in how we add an entity key and value to the URL query and in how we construct this at the call site. We could leave it at this and move on, but remember I said we want to ultimately write this code in a way that if you wanted to search for movies or podcasts, that would be trivial. Because all of this code is just typing out a bunch of enums, we're going to copy-paste it in. In the code snippets section of the teacher's notes, look for the iTunes entity.swift, iTunes attribute.swift, and iTunes media.swift files. So go ahead and replace the contents of iTunes media and iTunes entity files with all of this code. So let me go ahead and do that. Go over to iTunes entity, and then I'm going to grab all the code, paste it in, and then let's go over to iTunes media, and we'll get rid of all of this. Well, we don't have to get rid of it, but we'll copy-paste the code snippet in as well. And then finally, add a new file, a Swift file. We'll call this iTunes attributes, and copy-paste all that code over as well. Let's take a look at what we changed starting with the iTunes entity.swift file. So all we did in here is add types for all the entities described in the documentation. So we have a movie entity, a podcast entity, and so on. This means that when specifying a media type, if we go to iTunes Media, you'll see that every media type now specifies an associated value. The entity types match up exactly with the media type, so we can't pass incorrect arguments. Now, along with the entity, you'll see that we've added another associated value to model the attribute. This is modeled in the same way as the logic we did for the entity type, and if you go over to iTunes attributes.swift, you'll see that this is basically the same logic. Now, all we need to do is to modify the iTunes enum itself to properly account for the new endpoint values. Really, the only change we need to make here is to add the attribute key value pair, which is super easy. So inside the media type, we'll say if let attribute query item equal media.attribute query item, and then we'll append that to the result array. And now we have the search endpoint modeled exactly like we want to. Remember that the media type is doing all the work of surfacing these underlying values from the associated values that each case contains. So in here, we don't have to do any work. We just have to check, hey, does it exist? If yes, add it to the array. Now, search isn't the only endpoint we're going to be hitting. Let's add a value up in the main definition of the type. So let's add another enum member for the lookup endpoint. So we'll say case lookup. And here we're going to accept an ID of type int. And this is a non-optional associated value. And then we also want an entity. The entity here can be any entity, so we're going to specify the protocol type, iTunes entity, as the argument. This way, we can easily use a music entity or a podcast entity value as an argument. It is also going to be optional, since we know the endpoint considers it an optional type as well. Now, once we add that in, our switch statements in the various computed properties are going to raise errors because we're not covering all our bases. This is one advantage of using an enum. Since a switch statement has information about the range of values defined and knows if we don't cover all the cases, compiler errors arising from new endpoint additions means that we can't forget to define proper URL formats for all our endpoints. Now, the first thing we need to account for is a path, and this is easy, case.lookup. We're going to return a string that says /lookup. For the query items array, this is much easier than the search endpoint as well. So down here, we'll say case.lookup. We'll assign these to local constants. So ID, there we go. Let ID, let entity. And then in here, we'll just return an array with each item. So URL query item. For the first one, the string is ID for the name of the parameter key value pair, and the value is ID.description. For the second one, we'll say URL query item. The name is entity, and the value is entity.entityName. Now, this value initializer takes an optional string, so if this is nil, then we're not going to have anything, so perfectly okay. Let's test these out. So we'll go over to viewController.swift. This is wrong now, so let's get rid of all of this, and we'll say let search endpoint equal iTunes.search. The term is Taylor Swift. The media type is .music. And for the entity, we'll say .music artist. And then for the attribute, we'll say .artist term. Hold for background. We can also go ahead and print this out to see if we're doing everything correctly. And let's create one more. So we'll say let lookup endpoint equal iTunes.lookup. And for the ID, let's go ahead and find that stub.swift file. And we'll copy paste an ID over. So we want a collection ID or an artist ID. So let's grab that one. And we'll go back to the view controller. And since we're looking up an artist and we want the artist's albums, we'll say the entity is musicentity.album. Okay, let's go ahead and print the lookup endpoint.request. Oh yeah, we need to do .request over here as well. In between the two, let me just add a silly little string to print out so that it separates both URLs. If we run the app now, we should have URLs that match exactly what we use in Postman. Okay, so let's lengthen this out a bit. So itunes.apple.com/search. The term is Taylor Swift. The media is music. The entity is music artist. And the attribute is artist term. Perfect. For the lookup endpoint, we have the right base and path. And then we have an ID parameter, key value pair, and an entity. Now that we have an easy way to create whatever URL we need, let's write some networking code.